Okay, let's wait for the shared document to come up. Okay. We already have the shared document. What is this? That is the same table, because this is what the part 2 of the same video. So we already completed this table with almost the same answer as the textbook. Let's go to the next timestamp. Where is the next timestamp? That is what? The method is BDD, or backward divided difference. So number of times the step size is half. We have so many times. We have that. So about 10, no? About 10. In the figure, this is 11. 11 times the figure. So go to the next problem. So what is my error in the previous example? I am already computing for the absolute relative approximate error, but I thought that I am computing for approximate error. Approximate error is the difference between the current and previous approximation. So my formula is for the absolute relative approximate error, not for the approximate error. Okay. Take note, approximate error is only the difference between the current and the previous approximation. That's why we're not able to have these values. We have this absolute value. So next problem. So we are now on the number 24. We have now the example. What? Use a step size of 2 seconds. We already have the answer for this. This is the explanation for that. Step size is equal to 2 seconds. Let's find out the next problem where we can have a smaller step size. Smaller step size. So you can have this formula, slope, absolute relative approximate error, then the criterion. A criterion as multiple of 5. Multiple of 5. So what? Our answer is 3. That's the answer. Oh, this is the one that I'm talking about. So this is not approximate error, but what? True error. This is a true error. True error is true value minus approximate value. True error. So we can also compute the true error from this. If we know the true value. Okay. Next video. So we are now on the 25th video. Okay, this is now again. Okay. So this is using central divided difference. So what will change is the method. So we use in the previous video the what? The backward divided difference. This is central divided difference. As you'll notice, central divided difference is the best among the three. FDD, BDD, CDD. Among those three, central divided difference is the best. Particularly in this type of example. There are examples that that might not be the case. Okay? So in this particular type of problem, CDD is the best. So therefore, expect that calculators and Excel are using those type of approximation. So we can do it again. We can again complete this table. However, we will not do so because we already complete the table previously. This is almost equal. Just what? The only use for this is what? Example number 11. Only difference. Timestamp 2, 1, number 25. The only difference is the definition of the approximation equation. How do you know? How do you create this approximation formula? This is how you do it. Look, fx plus delta x minus fx minus delta x. Okay? Compared to the one above here, fx minus delta x. This is the what? Approximation almost similar to forward divided difference. But take note of the central divided difference. And therefore, the denominator here is 2 delta x. Because we are coming from x minus delta x going into x plus delta x. If you subtract, that is 2 delta x. This is the denominator. Okay, so we'll not do it. Practice it repeatedly. 1 to 10, 1 to 5. Okay. You will just have a different value for slope using this formula. The same procedure. This is the format. Screenshot this format. This is the format how to do it here. The same procedure here. The same. You have a format of how to solve this type of problem. That's find the next problem. So let's have the next one, which is what? Bisection method. Please tell me what are the assignment in this topic. I remember I gave an assignment here. So let's recall the assignment. Please give me and let's solve it. There are what? Drawbacks of this type of method. Bisection. Anybody who can recall or who can give me the assignment given before? Newton-Raphson. So very good method for solving nonlinear equations. Newton-Raphson. Still, Newton-Raphson has different drawbacks. What's next? Secant method. Okay, example. To aid in understanding how this method works, find the root of an equation, the graph of it was shown to the right. So we have a given effects. So, we're going to solve. Okay. So let's use our calculator to solve this. Okay. I think it could be solved on the previous type of allowed calculator that but look for the answer here. Let's look for the answer using this model of calculator. But I think you have to shift solve. Let's try shift solve. Okay. So we have what? 0 equal. This is correct. 0 is equal to x cube minus 0.165 x squared plus 3.993 times 10 -4. So we have this equation, shift solve. So for x, what is the initial value of x? From the figure, let us estimate 0.5. 0.5. And then solve. So the value of x is 0.146. Okay, what is, as you can see from the figure, 0.146, 0.06. The answer is about 0.06, more than 0.06. Okay, 0.4, 0.04, 0.06, 0.08, 1, 2, 3, 4, 5. So this is 10. This is supposed to be 0.02. So divided by 5. Okay. 20 divided by 5 is so 0.4. So 4. So this is not the correct answer. So therefore, let us use it again, but start with not 0.5, 0.05. So 0.05, 0.05, not 0.5. So if you are using 0.5, the answer must be 0.146. But 0.05, let's proceed. The answer is 0.6, which is correct. Which is correct from the figure. If you can see, take a look at the figure. 0.06 to 3776. Okay? That is very near 0.06 here from this figure. And that is the correct answer. Let us take a look from the textbook if that is the correct answer. That's why you can use your calculator to solve it by using shift solve. Okay? Using shift solve. Shift solve here. Shift and solve. You can read the brown letters here, solve. That's why you press shift and solve. Okay. Let's go to the video and look for the answer. So the answer is 0.0646. Very near. Our answer is 0.0623. Okay, or 24. Okay. This is the answer of shift solve. Okay. While this one is by using secant method. Secant method is the worst among the three methods. What are the three methods? Bisection method, Newton-Raphson, and secant method. Secant method is the worst one. But there are also advantages for secant method. That's why, as you can see, the value of x is equal to 0.06461, which is a little bit farther from the real answer. Okay, a little bit farther because the error here is 22.6. Okay. This is more like it. This is near to the actual answer, 0.0624. Our answer from the calculator is 0.0624. Okay, so the same answer. So let's go to the next. In our problem solving, you can use calculator and you can use shift solve. Why? Because that is allowed in the board exam. That is allowed. Okay, that is allowed. So it is very near to the correct answer, and the error is very small, negligible. How much is the error? 0.06. 0.06% is the error. Very small, negligible error. Okay, let's go to the next. This is the last one for chapter 2. Okay, algorithm of how to solve a problem using bisection method. So we already explained this. Bisection method. This is the first one in solving nonlinear function, bisection method. Okay, we will jump from the what? We will jump from the live problem solving, because the purpose of live problem solving is, of course, practice. Therefore, all of those problems in the live problem solving are already, but they are already explained. The problem solving part are already explained. So let us go to chapter 3, which is Gaussian Elimination, about simultaneous linear equation. So Gaussian. Okay, this one. Okay. we already explained this, no? But okay, let us explain another problem. I already explained this problem solving. I already solved this. Let us please take a look at the PDF of our textbook. Please give me a problem and let us solve using Gaussian elimination. Okay, so that you can see how it is solved easily in the actual. The discussion is more difficult than it is actually is. Okay, so there are what? Scary looking formulas, but in reality, if I show you how to do it, it is very simple. So please have, okay, let's do this. Please have a practice of Gaussian elimination. What else? Not only Gaussian elimination, Gaussian with partial pivoting. Okay. So, and then look for our textbook and look for exercises or problem solving under Gaussian with partial pivoting and Gaussian elimination. Okay. Because we will jump over the live. Okay. We are actually, that is actually our last video, Gaussian, no? We have an example here, and because the title of this video is example, expect that we already solved the example inside here. So please practice and practice from our textbook using Gaussian elimination. And next meeting, please give me an example and we will do it right away. Okay? We will solve the problem. But first, you have to practice. You have to practice. Okay? You have to try to practice and then give me the problem. Okay? So we are through right now, and I will just upload what? There is already an uploaded topic of us, and then I will just post in our GC. We'll just post it and continue the lecture and problem solving practice and some quizzes. So we'll have now starting to have quizzes, short quizzes and long quizzes, and going to the final exam.